Hello friends, you're welcome to our class today. Today we are going to be looking at, I want to actually differentiate between heat capacity and specific heat capacity, latent heat and specific latent heat. But before I do that, I would like to give a background introduction of heat energy because that is where those things came from. Heat energy, we know, is a form of energy that is being transferred between bodies of different temperature. Because of the difference in temperature between two bodies, there is always heat transfer when there is contact between these two bodies. So heat energy is a form of energy that is being transferred from a hotter body to a less hot body. So it is a form of energy transferred between bodies of different temperatures. And we know that the unit of energy is joule, so the unit of heat energy is also joule. So we should note that. So basically, heat energy is transferred between bodies of different temperature through different means. It can be through contact that we call conduction. So when two bodies are in direct contact with each other and heat is transferred from one to another because of the direct contact, the heat transfer is called heat transfer by conduction. Okay, but when heat is being transferred from one body to another, because even when they are not directly in contact with each other, but because of the movement of fluid in the form of either liquid or gas, that is heat transfer by convection. Are you getting that? Then heat transfer that occurs between two bodies that are not in contact by through electromagnetic wave, that is through wave, is heat transfer by radiation. But that is not what we are discussing now. We want to look at the difference between heat capacity and specific heat capacity, latent heat and specific latent heat. We should note that the formula for heat energy, H or E, equal to mc change in theta, where we basically know that this stands for heat energy, this stands for mass of the body, this stands for specific heat capacity, and this one stands for change in temperature, that is difference in temperature, change in temperature. So, but most times you see students not being able to differentiate between heat capacity and specific heat capacity. This is specific heat capacity. Okay, now what is the difference between specific heat capacity and heat capacity? Let us differentiate them. This one is C, this one is MC. Okay, we can say that specific or heat capacity is the quantity of heat required to raise the temperature of a body by 1 Kelvin. What do we mean? If this is a body, let's say the mass of this body is 30 kg. The heat that is required to raise the temperature, let's say the original temperature of this body was 30 Kelvin. The heat energy that is required to raise the temperature of this 30 kilogram body from 30 Kelvin to 31 Kelvin is what we refer to as heat capacity. It's the quantity of heat required to raise the temperature of a body by 1 Kelvin or 1 degree Celsius. If this is 10 degrees Celsius and it was raised from 10 to 11 degrees Celsius, the quantity of heat required to raise the temperature of this body from 10 degrees Celsius to 11 degrees Celsius is what you refer to as heat capacity. Or from 30 Kelvin to 31 Kelvin is what you refer to as heat capacity. So by definition, we said that heat capacity is the quantity of heat required to raise the temperature of a body by 1 Kelvin or 1 degrees Celsius. So mathematically, like I said, this is heat energy, this is the mass, this is specific heat capacity, and this is change in temperature. And I said that M and C put together is heat capacity. So if we make heat capacity the subject of the formula, we realize that heat capacity is the heat energy over change in temperature. That is the quantity of heat required to raise the temperature of a unit mass of the temperature of a body. The quantity of heat required to raise the temperature of a body by 1 Kelvin is heat capacity. Then what is specific heat capacity? Specific has to be specific, as the name implies. Specific heat capacity, see, from this relation, if we make C the subject of the formula, we are going to have C equals H all over M changing temperature. So what this is trying to say is that if we have a 30 kg mass of a body, let's say the same body, 30 kg of a body, and the temperature is 30 degrees Celsius, the quantity of heat required to raise the temperature of a unit mass, not the entire mass of the body, that is 1 kg mass of this body, from 30 degrees Celsius to 31 degrees Celsius, is what we will refer to as specific heat capacity. The quantity of heat required to raise the temperature of a unit mass of a body by 1 degree Celsius or 1 Kelvin is what we refer to as specific heat capacity. So the difference is that the quantity of heat requires to raise the temperature of the entire mass of a body, that body, if this is the body, the quantity of heat required to raise the temperature of the entire mass of the body, this body, by 1 Kelvin or 1 degree Celsius is heat capacity. But the quantity of heat required to raise only 1 kg mass of that body, no matter how big that body is, the heat required to raise only 1 kg mass of heat, the temperature of only 1 kg mass of heat by 1 Kelvin or 1 degree Celsius is what you refer to as specific heat capacity. That is the difference between specific heat capacity and heat capacity. We can also differentiate the two of them by their unit. If you look at this one that I call heat capacity, you know the unit of heat energy is joules divided by the unit of temperature is Kelvin. So the unit of heat capacity is joule per Kelvin. Joule divided by Kelvin is the unit of heat capacity. Okay? So the same, if heat capacity MC equals heat energy over change in temperature, like I said, the unit is heat energy is joule divided by the unit of temperature per Kelvin. But specific heat capacity C equal to H over M change in temperature. Therefore, the unit of specific heat capacity is heat energy joule per Kelvin or per kilogram, which is the mass per Kelvin. So that is the unit of specific heat capacity. Joule is the unit of heat energy divided by unit of mass kilogram divided by unit of temperature Kelvin. So the unit of heat capacity is joule per Kelvin, while the unit of specific heat capacity is joule per kilogram per Kelvin. So that is the difference. I've stated two differences between heat capacity and specific heat capacity. One is that the heat capacity of a body is the quantity of heat required to raise the temperature of the body by 1 Kelvin or 1 degree Celsius, while the specific heat capacity of a body is the quantity of heat required to raise the temperature of a unit mass of that body or 1 kg mass of that body by 1 Celsius or 1 Kelvin or 1 degrees Celsius. Secondly, the unit of heat capacity is joule per Kelvin, while the unit of specific heat capacity is joule per kilogram per Kelvin. Another thing I said we are going to differentiate now is latent heat and specific latent heat. Now, if you look at heat capacity, whether specific or not, it is the change in temperature that happens as a result of increase in the heat energy. Are you getting that? It causes a change in temperature. So, but in this case, the heat energy, in latent heat, the heat energy that the body gains does not change the temperature. Instead, it changes the state. We have three basic states of matter, at least at this level. We have the solid, the liquid, and the gas. So when the body changes from solid to liquid, it changes state. When it changes from liquid to gas, it is state that it changed but did not change temperature at that point when it is changing that state. So when a body changes from solid to liquid or from liquid to gas, the heat energy gained by that body at that point that change is happening is what we call latent heat. So latent heat is the quantity of heat required to change a body from one state to another at constant temperature. Latent heat is the quantity of heat required to change the state of a body at constant temperature. And then heat energy using latent heat is ml, where h is the heat energy, m is the mass of the body, and L is the latent heat of that body. Okay, so that is it. That's why I said that latent heat of a body is the quantity of heat required to change the state of the body, of a unit mass of the body. That's specific latent heat. Sorry, this is specific. It's the quantity of heat required to change the state of a unit mass of a body without changing its temperature. So what that means is that if you have a solid, for instance an ice, at the point where an ice is melting to water, that point is the heat energy gained by that ice to make it to melt to water is latent heat. At the point where water is vaporizing, turning to gas, the heat gained by that water at that point is latent heat. But what's the difference between the latent heat when a body is changing from solid to liquid and the latent heat gained by a body as it changes from liquid to gas? The one gained by a body to change from solid to liquid is what you call latent heat of fusion. So we can say latent heat of fusion is the quantity of heat energy gained by a body to change from solid to liquid at its melting point. And that melting point is the constant temperature. I repeat, latent heat of fusion is the quantity of heat gained by a body to change from its solid state to liquid state at its melting point. While latent heat of vaporization is this one. Latent heat of vaporization is the quantity of heat required to change the state of a liquid body to its gaseous state at its boiling point. Latent heat of vaporization is the quantity of heat required to change the state of a body from its liquid form to its gaseous form at its boiling point at constant temperature. So the temperature must be constant. You must mention that both in fusion and in vaporization, that at constant temperature, the quantity of heat required to change a solid body to a liquid body is latent heat of fusion. The quantity of heat required to change a liquid body to gas at constant temperature at its melting point. Of course, if you have mentioned this melting point, it is constant temperature. If you have mentioned its boiling point, it is still constant temperature. So that is what we mean by latent heat. Why specific latent heat is the quantity of heat required to change the state of a unit mass of a body at constant temperature. It could be at its boiling point or its melting point. And I've differentiated between boiling point and melting point. At melting point, the latent heat is latent heat of fusion. At boiling point, the latent heat is latent heat of vaporization. And what is the unit of latent heat? The unit is joule per kilogram. Since the unit of heat energy is joule, the unit of mass is kilogram. So the unit of specific latent heat is joule per kilogram. So that is how it is. We have been able to differentiate between specific latent heat and latent heat, specific heat capacity and heat capacity. I hope you understood that. See you when we come to calculation part of it. We will explain better.